So a couple of people have emailed and asked for more clarity on finding rules from tables. So I'm going to show you a couple of examples here to try to make that a little bit more clear. This first example will identify the steps, and then we'll go into a more tricky example for the second one. So the first thing that you want to do when you're looking at finding a rule from the table is see if you can find the starting value. And the start value, what you're looking for in the table, is simply the place where x is equal to 0. That's the place where before you get started in your foot race, you want to find out how far ahead of the starting line the y, the dependent variable, already is. So here, for example, when we look, we see that at 0, we've already got 7. So when our independent variable is 0, our dependent variable is already at 7. If this was going to be a money example, that would mean that before we've done any work to earn any money, we already have $7 in the bank. If it was a race example, like I was alluding to before, it would mean that at the starting line, before the clock starts, this person is already 7 feet ahead of the starting line. So this is where the pattern begins. Once we found where the pattern begins, and so here the pattern begins at +7. So that means that at the starting point, y is equal to 7, right? Before we get started, y is already 7. But then you have to also figure out how is y changing for each step of x. So every time x goes up by 1, how much does y change by? So the second thing that we're looking for is for the constant rate of change. Now, of course, there are patterns that don't go up by a constant rate of change, and you can write rules for them as well, but we're not going to focus on those right now because those are different stories for a different day. So we're going to just write rules for ones that have a constant rate of change. So we need to figure out what is the constant rate of change. So here when x goes up by 1, looking at the y column, you can see that x goes up by 3 each time. In other words, the constant rate of change is 3, but it's not just 3 once. It goes up 3 every single step. So we have to say that it's 3 times however many steps we've taken, and the number of steps we've taken, or the number of times we've moved, is our independent variable, is our x. So it's that rate of change times the x value. So that's our rule. So looking at a slight example, we can make things trickier by doing a couple things. First of all, taking a look at this table, you'll notice that I didn't give you the starting value. So we're looking for that start value where x is equal to 0, but it's not in the table. There isn't a space here that says x is equal to 0. So I'm going to have to figure out how x steps each single time so that I can figure out what it would be at 0 so I could put 0 in to this table. So let's take a look at how x is changing in the cases that we can see here. And so looking here in this first step, x goes up by 3 here. And on this side, as x goes up by 3, y goes up, down. Y goes down by 15 steps. From 2 to 4, now x only goes up by 2, and y goes down by 10. Here from 4 to 7, x goes up by 3, and y goes down by 15. So we have to ask ourselves, is there even a constant rate of change in this example? Because remember, there has to be a constant rate of change for us to write this rule. So is there a constant rate of change for one step of x? So let's think about it. If we're going down 15 for 3, for one step of x, we would say that we go down 15 for 3 steps. Well, looking at that, that's -5. Let's check out this one. Here we go down 10 for every 2 steps. Well, -10 divided by 2. That's -5. That's looking pretty consistent. That's kind of cool. And here, -15 for every 3 steps. Well, hey, that's also -5 because I did that one up above. So here we have indeed a constant rate of change, which means that that's how x is changing. So it means that if I'm only going one step here from -1 to 0, I must go from 25 to 20 is my 0 value. So now I've got my start value. I can highlight that. Got my start value at 20, and I know that my constant rate of change is down 5 for every step of x. So here, y is equal to 20, and it's a positive 20, so I put, you can either leave it without the sign, or you could even put a little positive in front of it if you want to. And then we're going down 5, so it's a -5 times x, right? Because it's going down 5 for every step of x. And that, my friends, is how you find the rules from tables. There's some great additional problems on IXL. I've posted on Friday a couple of IXL to work on. So go ahead and practice some more of those if this is one of those topics that you were wanting more work on. Thanks so much.